in the recording studio with Grace Kearns. You can't see the other peace sign. Today we will be talking about Stroop task and synesthesia, specifically grapheme color synesthesia, and we will be exploring the studies. So what we will cover is the abstract, which is the current study we did in class, the introduction, which is Stroop task and synesthesia, the methods, which are self-explanatory, the results where you'll be surprised, and discussion, what these findings mean for the future of research. So the abstract, 19 participants in a Stroop task walk into a bar. What happens, might you ask? Well, a congruency effect is found. But what does this mean for grapheme color synesthesia? Now, I could go deeper, but I don't want to spoil the rest of the presentation, But I'll give you a couple hints. The hints are the keywords. Keywords include Stroop task, grapheme color synesthesia, congruency effect, interference, and diagnostic criteria. So the introduction. It is J.R. Stroop's initial study from 1935 called Studies of Interference in Serial Verbal Reactions. And basically it's naming the word you read and then the naming the color of the ink. So they found interference in the second task. And they were like, whoa, interference, what does that mean? And it just has grown from there. So, continued. Synesthesia is a perceptual phenomenon where one cognitive pathway causes the involuntary stimulation of a different pathway. And grapheme color synesthesia is where the letters of the ABCs and numbers have associated colors. It's very individualized. It varies from person to person. And the Stroop task has been used to validate synesthesia, but there is a literature gap. So does synesthesia, having that, change the score? Now, getting more into the introduction, one second. Okay, I'm back. So it has been used to validate synesthesia, but there's a literature gap. So the gap is basically so they use synesthesia they use the Stroop task and the Stroop effect to show the validity of synesthesia, but they don't really, they're basically saying, okay, yeah, it's real. But they're not saying, what does this look like? How does this impact their scoring? And that's where the gap is. So I'm not going to try to say their names, but sources. Prior studies, they use synesthetes, which are people with synesthesia, and they use them as, they test them with the Stroop task, and then non-synesthetes, so just people who don't have synesthesia, are used as the control group. And it's a mixed design. This one source from 2026 focuses on the intricacies of synesthesia with regards to comparing synesthetes to non-synesthetes. And then within synesthetes, and the difference between an associator versus a projector, because they're different. There are different types of synesthetes, even within grapheme color synesthetes. So projectors report experiencing their photisms in external space, where other synesthetes, so associators, report experiencing their photisms in the mind's eye. So basically in their brain. It's kind of like the concept of, seeing it out in front of you versus just seeing it up here. It's all up here. Now the interesting part about this one specific study is that they thought that projectors and associators, because they're so different, that they would their scoring on Stroop tasks would be different, where they have interference, but they actually found that it's not that different, and so it's not really helpful to use a Stroop task, because associators would act like projectors, so it's unreliable to differentiate between the two. But it's still a step in the right direction. However, there's still a gap. Most of the research focuses on validity, and it would be beneficial to examine synesthesia's impact on cognitive interference as it relies on congruency effect the task creates. So the aim of this study is to provide a baseline, a foundation, something to build upon when researching further and doing more future studies on specifically grapheme color synesthesia and the Stroop task. So, methods. Participants, 15 female, 3 male, 1 non-binary, mean age of 24.6, and a standard deviation of 4.9. Materials were 4 sheets of paper, 1 for recording times. The other 3 featured basic numeric Stroop tasks that were congruent naming, congruent counting, and incongruent counting. My apologies. Methods continued. Procedure. Students placed into groups of 2 to 3, given the 4 sheets of paper, and asked to record other group members' times for the tasks. So this means that each, saying that a student is in a group of 2, they would pick who would be the researcher versus the subject, and then they would switch. So that's fun because they get to play both roles. However, confounding variable, potentially. Time accuracy, concentration, because we all did it at the same time. So it was really loud in the room. And the major confounding variable is that the first researcher had a better understanding of the task at hand than the first subject, because they got to see the task play out before actually having to do it themselves. So those are the 3 major confounding variables. Results time. Fastest time was congruent naming task. Slowest time was incongruent naming task. Mean difference of only 1.75 seconds. And you know what that means. ANOVA time. What did we find in the ANOVA, you might ask? Well, the ANOVA was significant. P is less than 0.0001, which frankly doesn't seem correct, but that's what I wrote in my paper, so I guess that's it. And that's really significant. So usually it's 0.05, which with confidence intervals and such. But so a p-value of that is real, wow. Anyways, so because the ANOVA was significant, you know what that means. Bonferroni post hoc time. And Bonferroni post hoc revealed that the congruent naming task, which had a mean of 12.24 and a standard deviation of 2.26, so standard deviation means it could be as much as 2.26 above 12.24 or as low as 2.26 below 12.24. So that's what standard deviation means in general. Congruent naming task significantly different than the incongruent counting task, so which had a mean of 19.38. And a standard deviation of 4.62. And so, that leads us to the discussion. So the main objective of this study was to create a baseline, and the findings align with previous studies on Stroop tasks showing validity and reproducibility. Research shows that there is an effectiveness in utilizing the Stroop task for determining synesthesia as well as understanding it. Unfortunately, there is still a literature gap. It doesn't explore impact of grapheme color synesthesia on Stroop scoring, and further research is needed. Thank you for watching. Smash that subscribe button. Click that notification bell. Here are my references. That's it. We're done. Thank you so much. It's been a great semester. We out.